Hey guys, welcome back to our video lecture series in physics. Today we're going to be discussing how we calculate average velocity. So you probably have heard of the famous astronaut Neil Armstrong. However, before he was a famous astronaut, he was a research test pilot. He actually set the unofficial world record for speed of an aircraft, and he did so using a specialized device. So in today's lesson, we are going to differentiate between speed and velocity, as well as see how we can calculate both average speed and velocity. And we'll also differentiate between constant velocity and average velocity and see what the main differences are between those two. And we'll continue to look at frame of references and see how that is important when we're calculating our average velocity. So in everyday language, when we use these terms, speed and velocity, we actually use them interchangeably. But in physics, they're actually not quite the same. So if you say that an object, let's say a car, was traveling at 60 miles per hour, that is telling me the speed, not the velocity. Now, why is that? So think back to our last lesson when we discussed the difference between vector and scalar quantities. Remember, scalar quantities include magnitude only. They don't necessarily tell you what direction the object is traveling in. Velocity, on the other hand, also includes a direction. So it's magnitude plus a direction. So if I was to then say the car was traveling 60 miles per hour northwest, that is your velocity because it has both a magnitude as well as a direction. So when we want to calculate our average speed, we simply take the average distance divided by the average time that it took to travel that distance. That will give you your speed. So for example, someone who takes 40 minutes to travel 20 miles north and then turns around and then goes 20 miles south, ending up at the same place that they started, that person had an average speed of 40 miles divided by 40 minutes. So that's 1 mile per minute, also 60 miles per hour. However, think back to when we talked about the difference between distance and displacement, right? The displacement would be 0 because essentially their change in position was 0. So average velocity, therefore, would be calculated by taking your displacement over the time. So 0 divided by anything is also going to be 0. So therefore, the average velocity would be 0 miles per hour. So let's go ahead and calculate the average speed and velocity of a person that takes 30 minutes to bike 5 miles west to the store, then returns home in 30 minutes via the same route. Again, let's calculate both average speed as well as the velocity. So for example, if you have an object that travels at 10 meters per second for 10 seconds, then travels 20 meters for 5-second interval, so he increases his speed dramatically and travels at 100 meters per second for the next 5 seconds. If you were to calculate the average speed, you would get 35 meters per second. But at no point did I say that that object was traveling at 35 meters per second. So let's go ahead and answer this question, and then when you're ready, we can move on. So you may have mentioned in the previous problem the difference between constant and average velocity. So constant velocity is very different from average velocity. Going back to the example in the last slide, if that object travels for 35 meters per second over the duration of the entire length of time, so that entire trip was 20 seconds, if that object travels for 35 meters per second for that entire duration, that is your constant velocity, right? The velocity was constant at 35 meters per second. So in this example, the car traveled the same distance as in the last example, but in the second case, the object's velocity was at 35 meters per second for the entire trip. So again, how is constant velocity different from average velocity? Let's go ahead and take a minute and write that in here. Okay, so in physics, Oftentimes, we will mark the position of a moving object as a function of time. So during a 3-second time interval, a runner's position changes from 50 meters to 30.5 meters. And we want to know what the average velocity was. Well, again, think back to that term displacement. So if we want to know the displacement or the change in position, we can essentially take its final position and subtract it by its initial position. So its final position, 30.5 minus 50 meters. That actually gives us a negative value, 19.5. And that tells us that the object was moving backward towards the reference point, right? So our reference point in this case being 0. So to calculate our average velocity here, we actually take our displacement, delta x, which we saw was negative 19.5, and we divide it by our total change in time, which again was 3 seconds, and that gives us an average velocity of negative 6.50 meters per second. So let's think about that for a second. Why is our average velocity a negative value? And again, look back to our displacement. And what does that tell us about the motion of the object? So another very important aspect of velocity is that it's always measured relative to another object. So we usually measure how fast a person walks or how fast a car drives relative to the ground, right? If we're talking about, in the last few examples, we talked about a car moving, right? When we say that it's moving at, let's say, 60 miles per hour, our frame of reference is the ground, right? The object is moving at 60 miles per hour relative to the ground. When we talk about the Earth revolving around the sun, our frame of reference is the sun, right? It is moving when we compare it to the sun. And those are our frame of references that are fixed points, right? Those points are not moving. So let's think about this scenario for a second, right? You're at the train station waiting for your train, and you notice that a train passes by, and you see people sitting inside, right? Let's pretend it's one of those express trains that go in the middle track. You're disappointed that it doesn't stop, and again, you see those people sitting, passing you by, and if you were to describe their motion, you would say they're going pretty fast. So is there a reference point maybe that those people on the train would not appear to be moving? Let's think about that for a minute. And when you're ready, you can put your answer in the blue box. So on these next 3 slides, we have some Regents problems. Go ahead and work on these problems now. If you need any assistance completing these problems after you've tried them, go ahead and watch the support videos provided by Mr. Chrysler and Mr. Brumleve. All right, so in conclusion, today we looked at average velocity and how it differs from average speed, as well as the difference between constant velocity and average velocity. We looked at those important vocabulary terms, vector and scalar, and how they relate to today's lesson. So what do you think was the most important thing to remember from today's lesson? Let's go ahead and put that in there. And if you can also add in some interesting fact or something that you learned today, that would be amazing. In the next few lessons, we'll continue talking about average speed and velocity, and then we'll also take a look at acceleration, which is an increase or decrease in speed or direction.